Okay? And these rigid transformations, they don't change the shape or size of a figure, they only change its orientation. Okay, so the first one is reflection. Okay, this is a transformation. That uses a line of reflection, like a mirror. Okay, and it often fits one of the following. It's often across the x-axis or across the y-axis, but it can also be across a vertical line or a horizontal line. It could also be across a diagonal line, but we're going to focus only on the horizontal and vertical lines. Okay, but if you have a point that reflects across the x-axis, what happens is that point goes from its original coordinates of A, B, to the new coordinates. Now think about what happens if you imagine a single point right here, AB, that's reflected across the x-axis. That means that this distance right here is extended across this line, the x-axis. And so it's going to have the exact same x-coordinate, but it's going to be exactly, or the exact opposite for the y-coordinate. So this will transform into the point A, negative B. Okay, if you reflect across this y-axis, so up here if we took this y-axis here and we reflected this point, we're going to take the distance it is horizontally from the y-axis, and we're going to extend that. Again, if you fold this point across the y-axis, what you get is the exact same y-coordinate, B, but it's going to be the opposite x-coordinate. So the point AB, when reflected across the y-axis, is going to be the opposite of A and then the same y-coordinate. So these are your kind of basic reflection rules. Okay, so I want you to see how would you plot the new points for this triangle if it says you're reflecting it across the x-axis. So I want you to see if you can plot those 3 points and then connect them using straight lines. My recommendation for this is don't try to memorize the rules for these. Again, it's up to you. If that works for you, that's fine. But my recommendation is to visually work through and draw in what the change would be, what that transformation would be. So here, if we're reflecting across the x-axis is this horizontal line right here. Okay, so it's basically the line y equals 0, right? So we're reflecting it across this line. What I would do is I would kind of sketch this, and then I would draw in the distances. So point P, when reflected across this line, is going to have the same x-coordinate, but it's going to go down this same distance. Okay, so point P is 3 units away from the line we're reflecting it across. So we're going to count 3 more units, 1, 2, 3, to find where that new point is. So here's our new point, P prime. Okay, if we do the same thing with R here is also 3 units away. So when we reflect it, it's going to be up 3 units. Oops. So here's R prime. So that connects these two. And then point Q is 1 unit away. So it's going to, when it's reflected, it's going to move up 1 unit. So here's Q prime. And then when you connect these together, remember on your MyOpenMath, you're going to click the polygon button. You're going to plot your 3 consecutive points, and then you have to go back to the first point that you plotted to enclose it, and that will give you this shaded in figure. Okay. Right, so counting is going to be, in my opinion, the best way to approach these, and that simply is because if you get a line that's not one of the axes, this rule doesn't specifically apply. You don't just change the signs of the coordinates. Okay, so if we take an example like this, and I'm going to talk through this one and then have you do the last one on your own. Okay, so if you want to find, if you take this original point, -4, -7, and you don't even have to be exact when you're sketching these, just in the right quadrant. So -4, -7 would be somewhere down here. We'll call that M. plot negative 1, 7 is going to be somewhere up here, and that's point F. And then point R is 3, 1. So again, it's somewhere about here. Again, doesn't have to be exact, but this is the figure, the triangle that you're looking across first. If you want to enclose it, you can. You don't specifically have to, but I'm just going to show you so that you can see what happens when you move these. All right, so if we take that image and we reflect it across the line x equals 7, is this a vertical line or a horizontal line? Where the x's never change, they're always 7. So here is the x coordinate of 7. So you have this vertical line here at x equals 7. This is the line that all of these points are going to be reflected across. Once you establish those two things, now you just start counting. Okay, so like look at the image here. So this point R, if it's reflected across this line x equals 7, what distance is this point from that line? And x coordinate of 3 is what distance from 7? 4 units, right? So this is 4 units this way. So when we reflect this point, we have to reflect it 4 units in the other direction. Well, what's 4 units to the right of 7? 11. So there's our x coordinate. And is there any change in the y coordinate here? No, the y coordinate stays the same. So our new point R, when we look at this, is going to be 11 and 1. And again, rather than trying to memorize some rule for this, you just count it. Okay, so do the same thing with F and M. I want you to see where would you put those points based on that same principle of counting the distance from that line that it's reflected across, and then determine which coordinates stay the same and which ones are adjusted, okay, and apply that adjustment to see what your new points would be. All right, so point F, when we look, negative 1 is how many units from 7? From negative 1 to 0 is 1, plus another 7 gives you 8 units. So when we mark the new point, it's going to be 8 units from that line of reflection. And what is 8 units to the right of 7? 15. And the y coordinate doesn't change, so that will remain a 7 as well. So the new point F prime is going to be 15, 7 for its coordinates. And then lastly, point M is how many units from the line of reflection? From negative 4 to 0 is 4. Then from 0 to 7, another 7. So 4 plus 7 is 11. So we're going to move 11 units to the right. 11 units to the right of 7 is 18. Same y coordinate, so negative 7. So there's our new point M prime. And again, if we were to connect these, you can see where that is, but just 18, negative 7 is going to be your new set of points. Okay. All right. So see if you can, if you didn't quite get it on that first try, okay, see if you can do it now with this last question right here. Okay, can you reflect the triangle across the line y equals negative 9 and find what the new coordinates would be, please? And again, you don't have to draw it into scale because you're just using reference, like the distance of a reference line. So if you look at point S as negative 9, 7, you just know it's going to be up here somewhere. That's point S. The point 1, 3 is going to be somewhere here. Again, it doesn't have to be precise, but it gives you a general idea. And then negative 4, negative 8 are going to be somewhere down here for point Y. Once again, if you want to leave them relatively straight lines, you can draw that in. Okay, so there's my 3 original points labeled. Again, and not necessarily to scale, or not necessarily exact, but they are somewhat to scale. Okay. And then I have the line y equals negative 9. Well, here's negative 8, so I go down one more. So it's this horizontal line right here. And now I can start counting my distances. So I'm going to go ahead and just start with the points up here. So S, when I count down, this is what total distance from the line y equals -9. Looking at the y coordinates. So from this point to the or to the x-axis, or the y of 0, is 7 units, plus an additional 9 gives me how many total? 16. Okay, and so when I look at that and I find that new point, I have to move down 16 units from -9, and that takes me to where? -25. That's my new y coordinate. My x coordinate stays the same. Okay, and so there's my first point, my new s prime. So -9, -25. Move to the next point, B. B is what distance from my reflection line? From 3 plus another 9 gives me a total of 12. So 12 units down from -9 leaves what new y coordinate? -21 is my new y. My x stays the same. So that's my new B prime. And then finally, my last point here, the y. What's the distance from my given point to the line of reflection? Just 1. So I go 1 unit down from -9 takes me to -10. So there's my new y coordinate. My x coordinate stays the same, so -4, -10. And so those would be the coordinates that I would find for this. Again, if I connected here, this is not to scale. It doesn't have to be. You're just using that as a reference. And again, once you fill these in, same with up here. Once you connect it, make sure you connect back to the original starting point that you plotted. Or if you were sketching the graph for this, connect back to the original plotted point to get the shaded region. Okay. All right, questions on that? All right, so that is the first rigid transformation for today, and that's just reflecting. So it'll change the orientation of the image, but it doesn't change the size. The last type of the transformation that doesn't change the size or shape is a rotation. Okay, and so rotation is defined as a transformation in which a figure is rotated or turns, and the direction of rotation is always counterclockwise. Okay, and the fixed point is usually going to be the origin. Okay, for these okay, unless it specifically says it's rotated about a given point. Okay, if it's just rotated, it's from the origin. Okay, and the easiest way to think about or remember that this is that the rotation happens in that counterclockwise rotation, and it's a little bit counterintuitive to you guys because when you think about a clock rotating, which is probably still the one thing that you see rotating more than anything else, the clock tends to rotate in that clockwise, obviously by the name, direction. Angles and in math rotate in the same direction that the quadrants count in. You guys remember how quadrants are counted? Quadrant 1 is right here. And then where's quadrant 2? Upper left or lower right? It's upper left, right? And so that's the rotation direction. So it rotates in this counterclockwise, then to 3, and then to 4. Okay, so the rotation, the key thing to think of first is that it happens in a counterclockwise rotation. Once you get that done, or once you get that down, the rest is not too bad. Okay, that is the hardest thing to remember. All right, now there are rules for 3 rotations that we're going to talk about. The first 2 would be the ones that would be probably used the most often. There's also, though, this last one of 270 degrees. These are all just 90-degree increments, because if we went back to 360 degrees, it would just rotate back onto itself, right? So we don't need to worry about the 360. But let's take a look at what happens when you rotate these points. Okay? And I'm going to use a point right here as the example. So this is the point 4, 1, right? And so notice what I'm going to do right here. I'm just going to copy this, and I'm going to paste it right on top of the original. So do you see how this is right on that original? Again, kind of disregard the figure. Right now we're only looking at this point. Okay, so if we take this point 4, 1 and we rotate it 90 degrees counterclockwise. So here I'm rotating it 90 degrees counterclockwise, and then I'm just going to map that onto itself. Notice where this point is now located. What's the x-coordinate of this point? -1, and what's the y-coordinate? 4. Do you see that you don't have to memorize this rule if you can recreate it in this same way that I just showed you? Because now what we see is the x-coordinate is the opposite of the y. So here we can come back up, and our rule is our x-coordinate is the opposite of the y. And our y-coordinate, here now it's 4. What was that in the very first piece? It's the x-coordinate, right? So this is your new rule. So a 90-degree rotation gives you an x-coordinate that's the opposite of the original y, and a y-coordinate that's equivalent to the original x. Okay? Now, I'm telling you these rules, but I'm also going to encourage you, don't memorize the rule, just rotate the image. Physically draw it and rotate it. It makes it much easier to do it that way. All right, let's go back here and let's look at let's go back to our original, and let's look at what happens at a 180-degree rotation. So I'm going to take this figure here, and I'm going to rotate it 180 degrees in the clockwise, or the counterclockwise rotation. So now notice where this point winds up. What's the new x-coordinate? -4. And what's the new y-coordinate? -1. And so what did I do with the original coordinates? A rotation of 180 degrees simply takes those original coordinates and it takes the opposites. Now that one not bad to memorize, right? If you are going to memorize one, that's the easiest one to memorize. And then what happens for this last example? What if I rotate this another 90 degrees in that counterclockwise rotation? Let's take a look at what happens now. Oops. Right, so this new point here now has a +1 for the x and a -4 for the y. And so again, if you kind of correlate that to the original point. So the new x-coordinate is the exact same as the original y. So we'll call that B. And our new y-coordinate is the exact opposite of our original x. So we'll call that -A. And so just by recreating that one single point and then physically rotating it, we're able to see all of these different rules. So now I'm going to take that away and get rid of that point because it was on that different question. Okay. All right. So what I want you to see is, can you plot this new figure here? Can you rotate each of those points 180 degrees? And now it doesn't have to specifically say counterclockwise. If it says it's rotating, it means counterclockwise. So make that assumption. Okay, but see if you can plot where would the new vertices be, and then connect those vertices to form your figure. So if you are going to be doing this and you don't have access to your device to just do a screen capture of it, hey, if you take and you draw it out just on a little piece of scratch paper. So if you see up here, I've kind of drawn this figure on a little piece of scratch paper and I labeled the coordinates of each vertex. Okay? So I didn't put the grid markings in there, I just labeled them. Okay? So if I'm going to rotate this 180 degrees, I go in the clockwise direction, here's 90 degrees, here's 180. I then just physically look at this rotation. So when I look at that rotation, and it's going to look like the following. So I'm going to copy this here really quickly. And so if I take this and I physically rotate it 90, 180, what I can see in my physical rotation is the same thing that you see here on my screen, right? I have my new x coordinate, -2, -1. I have my new x coordinate 1, -1, -2. I have my new x coordinate -2, -4. And I have my new set of coordinates, -5, -3. So what I can then do is I can just plot those points. So -2, -1, -1, -2, -2, -4, and -5, -3. Connect those, and again, whatever point you start with, click back on it to end your physical drawing, and that will enclose it with shading. Okay, and that is your completed answer. Okay? But again, if you just sketch it really quickly, rotate it, you see where it is. Okay? Does that make sense? Okay. All right, so I want you to try this next question over here. Okay? See if you can rotate each of those points 90 degrees. Okay? And find what the new coordinates would be, please. So once again, I'm not going to spend time memorizing this rule because it's so easy to just sketch it and physically manipulate that to see. So again, I would take the piece of scratch paper. I'd set up my coordinate plane, -4, 1. Label that, point X. 5, -1. Again, doesn't have to be completely to scale, but it should have a basic in the correct quadrant. So there's point L, and then 2, -5. Here is point P. I'm going to go ahead and connect these to form the triangle, but this is what I sketch on a piece of scratch paper. And then I'm going to paste this right over itself, and I'm going to rotate 90 degrees. Okay, map it back on. Now, again, as I look at this, I'm going to kind of move it over to a new spot to see it. What I can see is my X point down here. Here's my X point. Okay, this distance was a -4, but now it's a -1. And then I go down 4. So there's my new coordinate for X. I'm going to look at my point L. My point L is right here, so it has an X coordinate of +1, and it goes up 5. So there's my new coordinate. And then finally, my point P. Here, when I look, it has an X coordinate of 5, and it goes up 2 on the Y. So 5, 2. And I was able to get that just by looking at the image itself. Although if you did memorize the rule, you get -BA as each of your coordinates, and you can just go compare them to the original X and Y coordinates that were given. Okay? But again, it's up to you, and I know you're only getting this one day, or like a quick day before you're being quizzed on it. I would definitely just sketch it and physically rotate it. All right, try this last problem here on your own, please. So this is one, the 180-degree rotation means you're just changing the sign of the X and the Y. So this is the one that if you are going to memorize, that is the easiest to apply and recall. So the y, we're just going to take the opposite of the given y, or the coordinates, so -5 and +5. For d, we're going to take the opposite of the given coordinates, so +7, +8. For v, we're going to take the opposite, -3, -8. Once again, if you wanted to plot those out, physically rotate them 180 degrees, and you would get your same answers there.